Thank you. Okay. Hello. Thank you for coming to our talk. Okay. Today we would like to talk about a polarity effect observed when numerals are appended by a focus particle, and argue that it is closely related to the granularity interpretation of numerals. Okay. So here is the outline of the talk. Okay, and in the recent literature, it has been acknowledged that vagueness and granularity have an impact on polarity effects. And this work also contributes to this trend by reporting an unnoticed contrast between round and non-round numbers when associated with a focus particle more even in Japanese. A proposal in this paper is that in some cases, round and non-round numbers compete so that the presupposition introduced by Mo may or may not be satisfied. Okay, so let me first present the data. It has been noted that Japanese focus marker Mo even may induce different implications depending on whether they are in affirmative or negative contexts. So for example, in 1A, where Mo is appended to DP question 2, the affirmative version induces an implication that question 2 is hard, while the negative version induces an implication that Q2 is easy. In the same way, a numeral appended by Mo may induce different implications according to the context. So the sentence in 2A asserts that John solved 5 problems and also implicates that 5 is a large number. So a possible natural context for 2A is described in 2B, where John solved fewer than 5 problems last time, but this time he solved 5, which was rather surprising. Okay, when the numeral plus Mo appears in negative context, the sentence becomes ambiguous. One interpretation of 3A is a reading that context A in 3B describes. So suppose that John has 12 problems to solve, but he only solved 4 of them, namely he solved fewer than 5 problems. Under this reading, it is implicated that 5 is a small number. In the other reading describing context B in 3B, John solved 15 problems, so for 5 problems, he didn't solve them. Okay, so under this reading, 5 is implicated to be a large number. We will call these 2 readings the small and large number readings, respectively. Let me add that English even behaves differently from Mo. In a negative context with a numeral such as the one in 4A, English even is only legitimate in the small number reading. Okay. So now we can present our main data. Numerals appended by Mo show a peculiar polarity effect that's Ijima 1995 observes. In 6,ジョンは50問も解かなかった。ジョンは48問も解かなかった。In this sentence, while the 50 more sentence is ambiguous between the small and large number readings just discussed, but the 48 more sentence only has an interpretation where 48 is considered large and lacks the small number reading. Okay. So we claim that this difference is due to whether these numbers can be round numbers or not. Very intuitively speaking, 48 seems to be too precise to be used in the small number reading, but 50 can be a round number, which doesn't lead to awkwardness. Okay, in English, which doesn't show ambiguity with negation and only exhibits a small number reading, the sentence in 7 sounds awkward with 48. So we would say that this phenomenon may not be confined to the Japanese. So, and we also like to, at this point, like to note that the sentence with 48 could be improved given a context where 48 is considered to be in some ways significant. So for example, if solving 48 problems is the minimum requirement for passing some course, then the sentence in 7 and its Japanese counterpart improve. But we will not consider this type of context in this presentation. Okay, so another interesting aspect of this phenomenon is that this contrast seems to be dependent on what unit of measure the interlocutors assume. So in example 9, which reads 犯人の身代金要求からまだ24時間も経っていない、25時間も経っていない。The contrast is seen in 24 versus 25. So 25 sounds awkward in this context because 12 is a conspicuous unit in this context. Okay, so let me briefly wrap up what we have seen. The negative sentences with non-round numerals in the relevant unit of measure appended by mo or even may sound strange when they have a small number reading. Okay, so in the subsequent sections, we first lay out the logical forms we assume for the small and large number readings. And to do that, we follow Nakanishi 2006 and 2009, in that these readings are counted for in terms of the scope theory of Mo. And then we propose analysis of the contrast described in this section in terms of granularity functions associated with the interpretation of numerals and its interaction with the semantics and pragmatics of Mo. Okay, so Nakanishi 2006 and 2009 argue that Japanese Mo is best analyzed in terms of the scope theory of even idioms. In this theory, Mo introduces a scalar presupposition in addition to an additive presupposition, which is not relevant here, and its scale is always based on less likeliness. It also assumes that Mo moves to a propositional position at LF to take a propositional scope, even when it is appended to a DP or numeral. So under this theory, the contribution of Mo is represented as in 12a. Mo doesn't contribute to the assertive content, so it just returns the prejacent as is as its assertion. Its contribution is in the scalar presupposition it induces. The presupposition requires that the prejacent be the least likely one among its alternatives. This scalar presupposition is argued to be responsible for the hard or easy implications and the small large number implication that we observed above. I will illustrate how this works, but I would like to confine myself to the numeral examples. So let me skip some slides to go to slide 20. Okay, so but before doing that, I first have to make crucial assumptions about numerals and the unlikeliness associated with Mo. And first, numeral expressions like go or 5 in Gomon, 5 problems, are interpreted to be at least 5, not exactly 5. Second, the unlikeliness of Mo is equated with asymmetric entailment. So as shown in 16b, P is less likely than Q if and only if P entails Q and not vice versa. Together with the assumption about the at least interpretation of numerals, we can say that John solved 5 problems John solved at least 5 problems. Asymmetrically entails John solved 4 problems, John solved 3 problems, and so on. Okay, so the numeral plus Mo sentence in 18a has the LF in 18b. The focused element in 18b is the numeral 5, so the alternatives are produced based on this structure, yielding the set in 18c. For the scalar presupposition to be satisfied, the proposition that John solved 5 problems has to entail the other alternatives. So this is achieved by shrinking the set C to the one that only contains the prejacent and the proposition that include a lower number than 5. So since this, the prejacent proposition has the largest number among these alternatives, the large number reading results. The small number reading observed in the negative sentence, such as 19A, is yielded by the scope of relation in B, 19B. And the large number reading of 19A is the result of the scope of relation in 19C. Okay, so let me illustrate how these two readings obtained from these scope of relations. Okay, first in 20A, with the negation taking a wider scope than the numeral, but narrower scope than more, then the alternatives that satisfy the scalar presupposition should be the ones that have a larger number than 5. So this leads to the small number reading because among the numbers in the alternatives, 5 is the smallest one. On the other hand, if negation takes a narrower scope than 5, as in 20B, the scalar presupposition is satisfied when the numerals in the alternatives are lower than 5, which leads to the large number reading. So now we can describe when the 48 versus 50 contrast in 21 is observed. It is observed when negation takes a wider scope than numeral in the scope of more. So in other words, in the 48 more sentence, the numeral cannot be in the scope of negation. Okay, so the obvious question is why this should be so. Okay, now let me proceed to the proposal section. So the contrast between 48 and 50, as we noted, is seen as the contrast between non-round and round numbers. In other words, 48 refers to a more precise number than 50. Krivka 2009 claims that the coarsest scale principle in 22 governs this type of intuition, which says if a major expression alpha occurs on a scales that differ in granularity, then Adling alpha implicates that the most coarse-grained scale on which alpha occurs is used. So in the following two scales with different granularity, 50 is included in the coarser one, both in the coarser one and the finer one, but 48 is only on this scale. So the principle 22 ensures that 50 can thus be understood on the coarser granularity scale, but 48 is not. We follow the formalization of granularity proposed by Zaland and Sativa 2007 and Salt 2018, where the granularity function is assumed to be a contextual parameter of interpretation. This granularity function, gran I, maps a number n to the interval from n minus I times 1/2 to n plus I times 1/2, where I represent the granularity function, level. So 50 under this interpretation of the granularity function, under the interpretation of the granularity function, for example, 10 refers to the interval from 45 to 50. And 48, under the interpretation of the granularity function, 1 refers to the interval from 47.5 to 48.5, and so on. Okay. So under this setting, the sentence in 26A, John read 48 books with a granularity level 1 is true if and only if John read at least 47.5 to 48.5 books, because we are taking at least semantics for numerals. Likewise, John read 50 books with a granularity level 10 is true if and only if John read at least 45 to 55 books. Okay, so in these interpretations, we can see that 26A asymmetrically entails 26B, because the interval that is referred to by 48 falls within the range of interpretation of 50, but not vice versa. Okay, we argue that this ensures that 48 can be rounded to 50, but not vice versa. We formalize this in terms of 27 and 28. 27 defines the relative coarseness of granularity functions. Gran is finer than gran prime if found only if for any number n, the difference between the maximum and the minimum of the interval referred to by gran n is smaller than the one between the maximum and the minimum of the interval referred to by gran prime n. So gran 1 is finer than gran 10. 28 defines a condition where number n can be rounded to number n. So if the if interpretation of n with a finer granularity function is included in the interpretation of m with a coarser granularity function, then a proposition that includes n with the interpretation of the finer granularity function entails a proposition that includes m instead of n with the interpretation of the coarser granularity function when that proposition doesn't include negation. Okay, so let me propose a solution to why the contrast in 48 and 50 is observed. Our proposal is this: the alternatives included by induced by Mo and numerals are sensitive to the difference in granularity level of interpretation of numerals. So in particular, if n and m satisfy the relation in 28, namely n is rounded to m, but not vice versa, the alternatives for the computation of scalar presupposition of Mo plus n include a proposition with a number with a coarser granularity function. So the motivation of this proposal is that the scalar presupposition of Mo, when it is appended to numerals, checks asymmetric entailment. So if a round number is available, it also checks a proposition that contains it. So let me illustrate how this works for our examples. The sentence 30a includes a number that conforms to the condition in 28. The alternatives include the projectant itself under the ground 1 and the other proposition with lower numbers than 48 under the ground 1. In addition to these, we propose that we have to include this one, and John solved 50 problems under the ground 10. So in this affirmative context, and since John solved 48 problems under ground 1 entails John solved 50 problems under ground 10, the scalar presupposition is defined here. Okay. And in the case of 32a and 32b, 50 is not rounded to 48, so the usual alternatives can suffice. So so the alternatives are formed on the basis of the same granularity level that the projectant is interpreted with. So in either of the cases, the scalar presupposition of Mo are defined. Okay. In the negative sentences with a small number rating, 50 doesn't cause any problem either, because the alternatives to the projectant are formed based on the same granularity level as the one of the projectant, as shown in 33b and c. Okay, so these can be defined. But when it comes to 48, as in 34, this causes a problem. This is because the alternatives to the projectant have to include John didn't solve 50 problems under ground 10, this one. And as shown in 35, if John didn't solve 50 ground 10 problems, it is entailed that John didn't solve 48 ground 1 problems. So this leads to the undefined scalar presupposition of Mo, and thus the sentence doesn't sound. That sentence doesn't sound fine. Okay, so this cannot be defined. Let me turn now to the large number rating and explain why this do not lead to an acceptability. The crucial aspect of the LF in 36A is that the negation takes a narrower scope than the number. Again, 50 doesn't cause any problem because the alternatives are created based on the same granularity level as the one on the prejacent. In the case of 48, the LF in 37 produces the set of alternatives that include a proposition with a grant 10 interpretation as shown in 37B. But this doesn't cause any harm to the scalar presupposition because the prejacent entails all the alternatives. Sorry, I would like to add our prediction and then I will stop. Our analysis makes a prediction about the numbers that may not include this awkwardness. So if two numbers are not round and non-round number relation as defined in 28, the contrast is predicted not to show up, even if the number itself is interpreted with a final granularity level. And this prediction seems to be borne out because the single-digit number like 3 that are not rounded to the other number cannot be interpreted with a small number. Can be interpreted with a small number reading as shown in 39. So we can say John wa mondai o 3問とかなかった in this context. Okay. So another prediction is that acceptability may differ depending on the conspicuous unit of measure in the context. So as shown in 40 and 41, the same number, say 45, can be interpreted approximately or precisely. And the same kind of contextual factor comes into our cases. So as we saw above, and in 42, we observed that the contrast between 24 and 25, and this is because 25 is rounded to 24 if the unit of 12 is conspicuous in this context. Okay, so actually we have remaining problems with our analysis, but if you are interested, please ask us about that in the discussion section. Thank you very much.
Okay, any questions from the floor? If you have questions, please come to the front. And yeah.
Yes, thank you very much for a very interesting talk. So I have a question about cases involving continuous scales, like この箱は48グラムもない。This box doesn't weigh 48 grams. And I thought that this may pose a problem for your analysis because the key solution, if I understood the analysis correctly, the account goes as follows. So in the case of failed small number reading, essentially the scalar alternatives cannot be set appropriately because the section is too small, right? But on a continuous scale, you can think of different alternatives easily below 48 grams. So I was wondering if, so it seems like this analysis captures some aspects of the phenomenon, but it seems a bit too specific to the number cases. So do you have any comment on this kind of cases?
Oh, thank you for the question. And so you were saying that in the case of continuous scale, we cannot assume the alternatives that that may I thought that we could apply this present analysis to those kinds of cases. We simply thought that in those cases, and we could assume that maybe on 40 right, simply assume that on the lower numbers than 48 or whatever it is, but on 40, there's lower or larger numbers than 48, but as an alternative, but well, I'm not sure why you were saying that.
I was worried about this situation. So 48 invokes an alternative like 48.1, 48.2, etc.
Okay. Okay. Yeah, but so it should be dependent on the granularity scale. Granularity level we are assuming. So okay. So in those cases, maybe we should assume even finer granularity scale, maybe.
Yeah, but if you assume that, then the sentence should be fine. But intuitively, I think you get the same kind of effect.
Okay.
Whether the scale is continuous or discrete. So
okay.
what you say something like this? Either of these two cases, the granularity level is set in advance for the particular purpose of the context. And then I can kind of see how your analysis generalizes to those other cases.
Okay, thank you. So again, I at this point I think that that's also the case. Yeah, it's also the problem of granularity level, and if the granularity level is quite finer than for example 1 or 10, and I think we have a context where 48 is okay, and so so 40. The contrast between 48 and 50 can be observed when and when we assume that maybe we have 1 centimeters or 1, 2, 3, 4, 5, that kind of scale, but and 10 or maybe 5, 10 kind of scale. But if we go to a more if we go to a finer scale, maybe we can find a context where 48 is with a small reading is okay. I think so.
Right, that's the prediction. Yeah, and I think you need
to right.
Calculate that kind of context and see whether that sentence actually improves in those kinds of contexts. Yeah, thank you very much.
Yeah, thank you very much.
Thank you. Any other questions or comments? Okay. Next down, please.
Well, I have a comment on use case question. Can you hear me? Well, first of all, I have a question to you, Tanaka-san. So, alternative set, does alternative set have to be discrete set?
Well, so it has to be
discrete set. Can we just set it as a continuous infinite set? And scale is only relevant to maximum and minimal value. I mean, setting the range. Then, well, if you allow your theory to have the infinite, continuously infinite set as an alternative set, then use case problem doesn't occur.
Okay.
In the first place.
Okay, maybe I don't follow fully. Okay.
It's a bit a radical change to the theory, so we have to think about it more. Well, I will talk to Mizutani-san.
Yeah, thank you.
For the detail because.
Yeah.
Okay.
It's 30 minutes, that's kind of.
I think it's a very big move.
Yeah.
Uh-huh. Okay.
But it can be done easily.
Yeah.
Okay, we are out of time or less. So yeah, let's have the speakers again. Thank you.